Okay, today I'm going to start differentiation, new chapter 3. Right? Uh, did you watch the other videos? 2.9. From 2.9, actually, I'm not going to give you the proofs, equations for the exams or quizzes or anything, but just it's just you to let you know that there's a formal definition of limit. Okay, and which describes that whenever you find a small positive value, that the limit goes closer and closer, you find a corresponding small positive value in the x domain as well. So that's the only point of that definition, apart from what you learned before. Okay, so I think that it has a theoretical value of knowing that, but practically it doesn't have a lot of value. Okay, so I'm not going to spend a lot of time on that one. 2.9. I'll start talking about differentiation. Okay, so before starting that, how do you all think the way that the class is going? Are you happy with it, or do you need anything to be changed, or any suggestions? So far, so good. Okay. I just want to make sure that you guys learn. Okay, pass the class in the summer, because you take this class in the summer. I know that you really want to pass the class. So, and let me know what are the ways that I can help you to get there. Okay. Derivatives. So we're going to talk about the definition of derivative. The definition of derivative. First, let's look at what is the derivative. Okay, what does it mean? What is the derivative? Sometimes the derivative is expressed as a rate of change. Right, rate of change. And sometimes it's expressed as a slope of a tangent line. To a curve at a certain point. Right. And then more formally, it's known as the limit of the difference quotient. Right. So that's why we learned limits before we start talking about derivatives. Now, I would like to take this definition in terms of slope of a tangent line, which is more easier to show graphically. So I would start with that, and then I would go to more formal one, the limit of different quotient. Okay. So if I draw a graph of a certain function, some function, let's say the graph look like this, and I can find 2 points at A and some point, an arbitrary value of x, right? Some value of x. And then in between those two, I can draw a line which connects those 2 points, right? Let's say that point is P and Q, right? And what is the function value at that, for that x value of A? What is the function value? F of what? What is the value of the function? F of A. Very good. And then here, what is the value? Somebody answer for that one? This is the x value. Any x value. What is the value here? F of x, right? X could be anything. F of x. Does that make sense? This x could be A or B or C or something, right? Which is different than A. Now, I can write the slope of the secant. What is this called? A secant line, right? We call this one what? A secant line. Right? And then if I ask to write the slope of the secant line, how do I write it? What is the slope? How do I express the slope in this case? How do you find the slope of this one? What does it mean by slope? What does it mean by slope for you? Anyone? Slope? The angle. Yeah. How do you find the angle? Yeah. Yeah. Explain in your terms. That's okay. Yeah. Yeah. Sure. Uh-huh. Yeah. You want to find the angle of this one, right? So how do you define that angle? This angle, what I'm asking. Right? This angle, right? How do you find it? What is the tangent of that angle? Tangent value of that angle, what is that? If I take this as delta x, that is a change in x, and this is change in f, delta f. Now, what is this tangent of this angle? What is the tangent value of this angle? Anna? Very good. You know the answer, right? Change in f over change in x. Pretty good, right? So that's the slope that we call the slope. The slope is tangent of that angle. Okay, tangent of that angle. Don't worry, you can answer any question. Nobody laugh at you or anything. It's okay. You get a wrong answer. I'm open to that. So, what is delta F? Can anybody say what is delta F is? The difference between? Yes. Yes. So f of x minus f of a, right? And then what is the difference of x? X minus a. Brilliant. Right? This is called what is difference quotient. This is called difference quotient. Difference quotient. Okay, that's what it's called, difference quotient. Now I want to move this x, right, closer and closer to a. Now, what we're talking about is a limit, right? I move x towards a, right? Now, when I move x toward a, what would happen to this secant line? The angle of the secant line. What would happen to the slope of the secant line? It decreases, right? It becomes what? Gradually decreases, become this first, and it becomes this first, second, right? And finally, what would it become? It becomes the tangent, right? It becomes the tangent at P, tangent to the curve at P, right? Right? So when x goes to A, now we talk about limit. So what is the tangent? What is the tangent at P? Slope of the tangent to the curve at P is equal to what? When limit x goes to A, this is what we saw, right? Delta F over delta X, which is also equal to what? Limit x goes to A, right? F of X minus F of A divided by X minus A, right? Right? Does that make sense? Now, what we started with is a tangent of the secant line, right? And when we move x towards A, what would happen? It would become the slope of the tangent at point P, right? At point P on the curve, but x value is A. We call this F prime A. So what did we start? The second idea of derivative, slope of the tangent line to a curve at a certain point, right? What did we find from the limit? We found the slope of the tangent line at x equal A. What does that mean? That is the derivative of function f at x equal A. Does that make sense? Does that make sense? So this is also called, right, aka the derivative, right? The derivative of function f of x, derivative of f of x, derivative of f of x at x equal A. This is denoted by f prime. F prime is the notation for derivative of A. This is called derivative at x equal A. Isn't that easy? That's easy, right? Does that make sense to you? Right? So that, what is that? That's the third definition or third idea about derivative, the limit of the difference quotient. The limit of the difference quotient is equal to the slope of the tangent line at x equal at that value, which is also equal to the derivative. Does that make sense? Okay, that's called the f prime A, derivative at xa and x equal A. Now we want to make it a little bit fancy. Okay, we want to make it a little bit fancy. So we think that okay, x is equal to, we think x equal to, right? You see that color? Oh, let me take another color. We think that x is equal to A plus h. H is some value that is greater than 0. Okay. Now, how do I write that f prime A? By using that. Now, what is x? Sorry, x minus A. X minus A is equal to what? If x equals A plus h, what is x minus A? H. Very good. Right? It's equal to h. Now I can write, right, f prime A, that is the derivative of function f at A, is equal to limit. Now when x goes to A, what happened to h? when x goes to a, what happened to h? What would happen to h? Where would it go? Look at the equation. X minus a is equal to h. Now, when x goes to a, what would happen to x minus a? Decreases. Where does it go? 0. So h goes to where? 0. So here what we have is x minus a. X goes to a, right? When x goes to a, where does h go? To 0, right? Does that make sense to everybody? So this limit changes to h goes to 0, right? And instead of f of x, what would I write? F of, what is x equal to? What is x equal to now? A plus h. So I can substitute a plus h minus what? F of a divided by, what is x minus a? H. So that's the definition of derivative at a. Is that difficult? Is there anything that you don't understand in that explanation? Pretty easy, right? So now for derivative to exist at that point, what would happen? What should happen? For this to exist, for this f prime a to exist, what should happen? What should happen? Huh? If f prime a is there, the limit should exist, right? This limit should exist to f prime a to exist, because limit has to be there, right? We found some cases that limit does not exist. In that case, what? The function is not derivative at that point. You see what I mean? The limit should exist. What condition does it satisfy for the limit to exist? What are the conditions need to be satisfied? What do you mean by the limit exists? The right hand limit should be equal to the left hand limit, right? If the right hand limit and left hand limit equal to each other, what does that mean? The limit exists. If the limit exists, if this limit exists, that means the function has a derivative at that point. Does that make sense? So we learn about limits and the existence of limit, right? And now we learn about the derivative. Everything is connected to each other. Okay? Everything is connected to each other. Now, that's the definition of it. That's the definition of it. And from that, you should be able to find, this is just a side work, I would say. Equation of a tangent line. Now, let's say you have a, I'm sorry, to take let's say we have a function like this, right? And then you have a tangent at that point. Okay. Let's say this function is f of x. Okay. And then this is point A. Right? Right? Now, what is the slope of the tangent at that point? What is the slope of this tangent line? Say this is the tangent line. And what is the slope of this tangent line? We just talked about it. What is the slope of the tangent line? Remember when we talked about it, right? The secant line became tangent line, right? And the slope of the tangent line is equal to what? Huh? Yeah, that's right. But what is it called? Slope of the tangent line is equal to f prime a at a, right? Slope of the tangent line at to the curve at P or at x equal a is equal to f prime a. So what is the slope of this tangent line at this x equal a? If the function is f of x. You know what is the slope of the tangent line is? You know the answer, but you don't tell me. What is the answer? Huh? The slope of the tangent line is equal to what? The derivative of the function at that point. So what is the derivative at that function of that function at that point? F prime a. So the slope of the tangent line is equal to what? F prime a. F prime a. Right? Now, in the previous course, maybe in 180, you have taken 180, or in your high school, you might have taken algebra or pre-calculus, right? Pre-calculus. In pre-calculus, how did you find a equation of a line? How did you find the equation of a line? So now you know the slope, right? F prime a, slope of that line. So if I have a point here, x and y, this is x, right? What is this? This is y. Okay, that is y. And what is the value of function here? Is this point at x equal a? What is the value of the function? If function is f of x, what is the value of the function at x equal a? F of a. Yeah. Shout out. You know the answer. F of a. Okay. Now, what is the slope? The slope is the tangent, right? Tangent of this angle. Does that make sense? The slope is the tangent of that angle. And Connor earlier said that the tangent of that angle is what? The difference of this y coordinate divided by x coordinate, right? So what is that now? Tangent, slope of the tangent line is f prime a, which is also equal to what? What is the difference between delta x? X minus a, right? And these two, what is the difference between vertical distance? What is that? From the graph, Bryson? What is this distance? Now, what is the value here? Y. This is what? F of a, right? So y minus, your answer is correct, but the values need to be changed. A y minus f of a. Does that make sense? Right? These two equal, right? Right? Now, if I write y minus f of a equals f prime a times x minus a, this is the equation of the tangent line at x equal a. The equation of the tangent line at x equal a. Right? This is how you found the equation of a line. You need the 2 points to find the equation of a line. Right? And so, for slope and 1 point. Right? You have given the slope. Now slope is equal to what? Y minus f of a divided by x minus a. That slope is equal to f prime a. Right? Right? That makes sense? You all good? Okay. So that's a This is like y equals m x plus b type equation. I can reformulate that into that, but I'm not going to do it right now. Okay. So if you find what is the advantage of that? If you find f of a and f prime a at x equal a, right? Now you are given a function f of x. If you can find f of a and f prime of a, f a and f prime a at x equal a, you can find what? You can find the equation of the tangent line. Why? Because you all need f of a and f prime a, right? You are given a function, some function, and you are asked to find the equation of a tangent line. You find f of a and f prime a, then you can find the equation of the tangent line. Does that make sense? Right? You find f of a and f prime a at x equals a, you can find the equation of the tangent line at x equal a. Equation of the tangent line to the curve of f of x, right? To the curve of f of x. Okay, let's do this example. Let's do this example. You are asked to find color example. Okay. So you are asked to find, you are given f of x equals x squared, right? Find the equation of the tangent line at x equal 5. Okay, I'll give you 2 minutes, and then we'll discuss. 2 minutes, okay? No more than that. So how do you find? So what do you need to know? F of a and f prime a. So how do I find f prime a? What is the definition of f prime a? Limit h goes to 0, f of a plus h minus f of a divided by h. Right? What is a in here? What is a in here? 5. Good. 5. Let's find f prime a first. Because f of a is here, right? F of a is what? If you substitute value 5 to that function. Yeah, I see. Make 3 groups. Like working in groups. You are given problems in the class. Use the definition to find f prime a. Okay. To find f prime. Sitlali, how are you doing? It does make sense to you?
It did. I'm currently working on it. So.
Okay. If anything, if there's any question, please don't hesitate to ask. Okay.
I appreciate it. Thank you.
Okay. So already past 3 minutes. So what do we need to find? We need to find f of 5 and f prime 5, right? Makes sense? By definition, okay? By definition, f prime of 5 is equal to what? Limit h goes to 0, f of 5 plus h minus f of 5 divided by h. Does everyone understand that? Okay, what we did was we substitute 5 instead of a in that definition, right? So you have limit h goes to 0. What is f of 5h? So it's what? 5 plus h square, because it's x square, right? Minus 5 square divided by h, right? And then you have limit h goes to 0. This is what? 5 squared, that means 5 squared plus 2 times 5h, that is 10h, plus h squared minus 5 squared divided by h. Does that make sense? Does that step make sense? Good? Is everybody good? Okay, now I can cancel to this, right? Then you can take out 1h from the numerator. Limit h goes to 0, take 1h, that's 10 plus h divided by h. Then you can cancel these two, right? And what is the limit of that? When h goes to 0, 10 goes to 10, plus when h goes to 0, h goes to 0, right? The answer is 10, right? The answer is 10. So what is f of 5? What is f of 5? What is f of 5? 5 squared, which is equal to 25. Does that make sense? Now, what is the equation of the tangent line? It is y minus f of a, right? Y minus f of a. This is the general equation, equals to f prime a times x minus a. So it's y minus what? F of a is 25 equals f prime a is 10, x minus 5. Right? So that's the answer. And then you can simplify this a little bit, 10x minus 50 here, and then you have y minus 25. So you have y equals 10x minus 25. The equation of the tangent line. This looks like y equals mx plus b, right? So linear equation. That makes sense? Are you find that? Right? Good. Okay, so you can do many problems in this type.
I have a question before we move on.
Yeah.
I think I missed where we got the 10H.
You missed where you got the 10h?
Yeah.
Okay, so let me explain again. So do you understand the definition? This limit h goes to 0, f of 5 plus h minus f of 5.
Yes.
That comes from the definition. Then what I did was 5 f of 5 plus h is 5 plus h squared. Do you understand that one?
Yes.
Then this is 5 squared, okay? And then divided by h. Now what you do is expand this. How do you expand this? If you have something, maybe that's the part you didn't understand. If you have something a plus b squared, right? You can write that a squared plus 2 times ab plus b squared.
Oh, that's a factoring portion, correct?
So that's a plus b times a plus b. So if you do 5 plus h times 5 plus h, you get 5 squared, 2 times 10h, that's 2 times 5h, that is 10h plus h squared.
Perfect. Thank you.
Make sense? Any other questions? Good. Let's move on. Okay, so this is the example 29 from your textbook. Example 29 textbook. Now you are given an equation. Use the limit definition to compute f prime a and find an equation of the tangent line. Use limit definition to find f prime a and find an equation of the tangent line at x equals 3. So this is the function f of x equals 2x squared plus 10x. Now we added another term, right? Previously it is just x squared, so we added a term. Okay. Now, what is the by definition? F prime 3 is equal to what? Limit h goes to 0, f 3 plus h minus f3 divided by h. Right? Now what are we doing? We are substituting these values to the function, right? So what is that? Limit h goes to 0. What is f of h plus 3? 2 times 3 plus h squared, right? Plus 10 times 3 plus h. Does that make sense? Minus f of 3. What is f of 3? 2 times what? 3 squared, right? Plus 10 times 3. Are you with me? And divided by what? H. Now you have to use your algebra knowledge. I need algebra. Okay. This definition is simple, but you need a little bit of algebra to solve this. Okay. Now again, a plus b square type of thing, right? What did we do? 2 times 3 squared plus 2 times 3, right? 2 times 3h, right? 2 times 3h plus h squared, right? Plus 10 times 3, that is actually, I'll write in the same way. 10 times 3 plus h minus, what is the, how do I simplify the inside? This is 3 squared, that is 9. 9 times 2 is 18. 18 is times 18 plus 30, 48. Right? 48 divided by h. And limit h goes to 0. This is what? This is 2 times 9, right? 3 squared is 9. Are you with me? 9 plus 6h plus 2h squared, right? Did that make sense? Sorry, h squared. I had to multiply by 2 from outside. Yeah, let's put 2 in here. Yeah, I didn't multiply by that. Plus 30 plus 10h minus 48 divided by h. And again, limit h goes to 0. Now here what I have is what? 18, right? The first term, 2 times 9 is 18. And then you have plus 30, right? So you have 18 plus 12h plus 2h squared plus 30 plus 10h minus 48 divided by h. So I have 18 plus 30 is 48, and this is negative 48. Right? That makes sense? So I can remove this to this and this. Right? 48 to 48. And what do we have in the numerator? 12h plus 10h, that is 22h. Right? And then you have 2h squared, right? So you have limit h goes to 0, 22h plus 2h squared divided by h. Now I can take out 1h, right, from the numerator, and I can cancel that to the denominator h. So what do you have? You have limit h goes to 0, 22 plus 2h, right? The first one is a constant. You can use the summation rule or summation law. So you get 22 plus 0, that is equal to 22. Right? So f prime 3 is equal to what? 22. Right? F prime 3 is equal to 22. Now, to find the equation of tangent line, what else do you need? What is the other information, piece of information you need? Anybody knows what that other information that you need to find the equation of tangent line? You found f of f prime 3, then what else? f3, right? So what is f of 3? Is equal to, he found f of 3, right? Here, 48, right? 48, right? And then the equation of tangent line is what? Y minus f of 3 equals f prime 3 x minus 3. So y minus 48 equals f of 3 is 22, x minus 3. That's it. Then you can simplify it a little bit. This is y, and you can add this 48 to this side, and this is going to be negative 66, right? 66, so you get 22x minus 18. Is that right? My calculation correct? So you can do many problems like this, right? You can do many problems like this. The same thing is that you need to, the only thing is that you need to be a little bit good at algebra for some problems, because you need a little bit of algebra to solve this. Okay? Is that good? Make sense? Let's take let's take another one, another example. This is the problem number 37 from the book. So you are given a function f of x equals 1 over x plus 3. Find the equation of the tangent line at x equal -2. Okay, you can have a couple of minutes to see whether you can do the problem. And then I'll tell you what to do. So -2, you find the equation of the tangent line at x equal -2. So what do you need to know? You need to know x prime -2 and x -2. Yeah, I see that's most of you have started. Okay. Yeah, so when you find f of something, just substitute for x. And then if the function, just substitute for x. And then solve it. As I said, you need a little bit of algebra to do that. Okay, so we can find f prime negative 2, right? By definition, it is limit h goes to 0, f negative 2 plus h minus f of negative 2, right? Instead of a, we just write negative 2. That's it. And divided by h. And let's see what would happen if I substitute this. Now, f of negative 2 plus h is 1 over, sorry, I need to write limit h goes to 0. I need to write 1 over, instead of x, I write negative 2 plus h plus 3. Minus, what is this one? 1 over negative 2 plus 3. Right? Divided by what? H. Right? Now I have to solve. Inside that I get 1 over 1 plus h minus, what is this one? Plus 1 at the denominator, 1, and it's just 1, right? This is 1. So by h. And then you have limit h goes to 0. 1 plus h is the common denominator, right? And you get 1 minus 1 plus h divided by 1 plus h. And this is in the denominator, right? Like that. Now what would happen? This 1 plus h comes to the denominator, right? This 1 plus h comes to the denominator, right? So what would happen? You can write limit h goes to 0, 1 plus h, 1 minus 1 minus h. This cancel to that, and you get what? Limit h goes to 0, negative h divided by 1 plus h times h, right? There's a h here. I forgot that one. There's a h here. Right? And then you can cancel this to that. What do you have now? Limit h goes to 0, negative 1 divided by 1 plus h. Right? On the numerator, you have negative 1. On the denominator, you have 1 plus 0. What is the answer? Negative 1. Does that make sense? Now, once you have negative 1, you can find the equation of tangent line. The equation of tangent line is what? Y minus f of negative 2 equals f prime negative 2 x minus negative 2. Okay, that becomes positive 2. So what is f of negative 2? F of negative 2 is 1. Y minus 1. F prime negative 2 is negative 1, right? X plus 2, right? So you can write y is equal negative x, right? This is negative 1. This side you have negative 2. That becomes negative 1. Does that make sense? Is it all good? So that's how we find. You can do that for anything. You can do for that for anything. Right? I can work out like 10 examples, it will be the same. Right? Does that make sense to everybody? Okay. So what if you are given any function f of x, which looks like mx plus b? What is that function? What do you call that function? There's a name for that. This is slope, m is slope, yes. What do you call that function? Huh? Linear function. Very good. It's a linear function. Why it is called linear function? Because it's a straight line. Yeah, it looks like a straight line. If you connect all the points that on that function that represent that function, right? That becomes a straight line. So this is called linear function. Now let's see what would happen if you find a derivative at any point of a linear function. So how do I find f of a? A is any point, okay? F of a, what is f of a? How do I define f of a? What is the definition? Limit h to 0, h goes to 0, then f of a plus h, yeah, minus f of a divided by h. Now, substitute this to the function that I have given. What is that? Limit h goes to 0, mx plus b, right? M times a plus h, right? A plus h. Now, instead of x, I put a plus h plus b. This is b. This is not b, this is h, okay? I just need to transfer that. Minus, what is f of a? ma plus b. Does that make sense? Divided by h. Okay. Now what happened? Ma cancel to ma. Right? You have m of ma here, right? I will write it explicitly. H goes to 0. This you have ma plus mh plus b minus ma minus b divided by h, right? So ma cancel to negative ma, positive b cancel to negative b, right? What do you have? And h cancel to h, right? You have limit h goes to 0, mh divided by h. So if we divide mh by h, what do you have? M. What is m? M is a constant, right? Slope. It's a constant for linear line, linear function, right? So this is what? What is the limit? What is f prime a? Is equal to what? Is equal to m, right? So what? What is this? What does it tell us? At any point of x, f of the derivative of a linear function at any point is equal to m, slope, right? So for example, if you are given f of x equal to x plus 1, what is the derivative of this function at x equal to? What is the derivative of this function at x equal to? What did I say earlier? If you have mx plus b type of function, the derivative at any point is equal to m. That means the slope, right? So for this function, what is the slope? 2. Now, what is the derivative at 2? At x equal 2? 2. What is the derivative at x equal 3? 2. right? What is the derivative at x equal 4? It is again 2, always 2. It's a straight line. Same derivative, same. Does that make sense? So it is a straight line like that. So the slope of the tangent line does not change at any point. The slope of the tangent line is equal to the slope of the curve. That is m. Clear? Good enough? Okay. Now that's a beautiful thing. And there's the other one. My function f of x is equal to constant b. Right? So what is f prime of a for constant b? What is f prime of a for constant b? Let's find it out. Limit x goes to 0, right? F of a plus h plus, minus f of a divided by h, right? So what is f of a plus h for this function? Is there any x term in there? No, it's a constant function, right? It's a constant function. So what is f of a plus h? Anybody? What do you think, Bryson? It's okay, you might get wrong, but tell me answer. The question is, what is f of a plus h for this function? F of x. F of x is equal to b. B is a constant. B is a constant. But my question is, what is f of a plus h? Where do you substitute a plus h in f of x? If you have an x term, you substitute it. If you don't have x term, what? You don't. So what is the function value of a plus h? It's b. It's a constant function, right? No matter whatever the x value is, its value is b. It's like this. You have f of x equal b means it's y equals b. That means at any x value, your function value is the same. No matter what the x value is, your function value is the same. Does that make sense? Right? So what is f of a plus h? B. What is f of a? B divided by h. What is the value? This is limit h goes to 0, 0. What is the value? 0. For constant function at any value of a, the derivative is 0. Right? Why? What is the slope of the tangent? What is the slope of this line? 0. 0 slope is something parallel to the x-axis. Okay? Does that make sense? Good enough? Anything confusing? Ask questions, okay? These things are very easy if you do really understand what's going on. Right? Asking questions, working out more problems is the only way to understand these things, right? Very easy, very, very easy. Okay. Now I want to show, okay, let's take example 17 from the book. Example 17 from the book. It's 3.117. Yeah, it's the same thing. You have f of x equal 7x minus 9. Use the limit definition to calculate the derivative of linear function. So you can use the limit derivative. the slope. Limit definition, sorry, limit definition. To calculate the derivative. So what is the derivative of this function at any point? What is the derivative of this function at any point? Now you should be able to tell me. 7. Right? You can use the limit derivative and then check whether your answer is correct. Right? Can you do it later and see whether you get the 7? Use the limit derivative. Instead of x, you substitute a plus h, right? And a. So basically use this definition. Limit h goes to 0, f of a plus h minus f of a divided by h. This is the limit derivative definition. This will give you f of a, right? At any point. You can put any number for a, but you get the same answer, 7. Right? Okay. I would like to show you a case where the limit does not exist. Let's take this function, f of x equals magnitude of x. Okay. So I'm going to find f prime 0 for this function by using limit definition, right? What is the limit definition? Limit h goes to 0. Now a is what? What is a? 0, right? So f of 0 plus h minus f of 0 divided by h. Right? So 0 plus h is h. So you substitute just h instead of x. So you get what? Magnitude of h. Right? Minus what is f of 0? Magnitude of 0, that is 0. Right? And divided by h. H goes to 0. Right? And then limit h goes to 0, magnitude of h divided by h. Now magnitude of h is defined as this. Magnitude of h, okay, magnitude of h is defined as h when h greater than 0 and negative h when h less than 0. What does that mean? If you substitute any value that is negative, if you want to get the magnitude, you simply multiply that by -1. Let's say, right? For example, let's say you want to find a magnitude of -2. What would you do? You multiply that by -1, right? That's what they say. When h is equal h less than 0, right? For any negative value, magnitude of h is equal to -h. You put h and multiply by -1. That's simple, right? Okay. Now, I want to look at this carefully. I want you to look at this carefully. When h, now for limit to x is what should satisfy? The right hand limit should be equal to the left hand limit. Okay. Okay. What is the right hand limit? Limit h goes to, right hand limit is h plus, right? H plus. When h is greater than 0, what is h? H magnitude means? Wait, it's just h, right? Divided by h, which is equal to limit h comes to 0 from the positive values is equal to 1, which is equal to 1. Right? And then the limit h goes to 0 from the negative values. Now, what is this? h coming from negative value from this side to 0, right? So what is the value of h in that case? What is the function? Minus h divided by h, which is equal to limit h goes to negative zeros, -1, which is equal to -1. Now what is the conclusion? Right hand limit is not equal to left hand limit. That means the limit does not exist. Limit does not exist. Right? That means the function is not differentiable at x equal a. Sorry, x equals 0. So if you draw f of x equal magnitude of x, you will get a function like this. Your curve looks like that. The limit does not exist at that point. So this limit does not exist. But is it a continuous function? It is a continuous function. Right? There's a limit for x magnitude. This function has a limit, but its derivative doesn't have a limit. See it doesn't, I mean, derivative does not exist, right? Derivative doesn't exist. I'm sorry, but the function is continuous. It is not differentiable at x equals 0. Okay. See, that's a special case. Does that make sense to you? And there's another special case. I take that one as well. G of x is equal to x to the power 1/3, which is also equal to cubic root of x. Cubic root of x. Okay. Now I will try to find g prime 0. G prime 0 is equal to what? Limit h goes to 0, f of 0 plus h minus f of 0 divided by h. So this is limit h goes to 0, f of 0, that's f of h, that's h 1/3, right? Minus 0 divided by h, right? So you get limit h goes to 0, 1 over h to the power what? 2/3, right? 2/3. Now, when h goes to 0, what would happen to the limit? Where does the limit goes? When h becomes smaller and smaller, 1 over h becomes larger and larger. It goes to infinity. Does the limit exist? Limit does not exist. Now, what happened is this. The function has something like that. The function has a slope, a vertical portion at x equals 0. Vertical slope means the highest slope, infinity slope. So function is not, doesn't have derivative at x equals 0, but the function is continuous. Okay, the function is continuous, but it doesn't have a, it does have a limit, right? It is not differentiable at x equals 0. The difference quotient limit does not exist. See the change? Okay. All right. Is there any question based on that? So a few things that you need to understand. What did we learn? capturing what we learned in that chapter. This is 3.1, okay? 3.1, what did we learn? We learned that f prime a is equal to what? Limit x goes to 0, f of a plus h minus f of a divided by h, right? That's one thing. And then we learned that equation of tangent line at x equal a equal to what? Y minus f of a equals f prime a times x minus a, right? And then we learned that if you have linear function f of x equal mx plus b, f prime a is equal to m for all values of a. This symbol means all values, okay? All values of a. And then if you have fx equals b, right? What is f prime a? What is the f prime a for a constant function? Can you go back and see? What did you get for constant function? What is f prime a for constant function? Right?
0.
0. Good. 0 is 0. All the values of a. Why? Remember the slope, right? We talked about the slope. Remember that slope? The slope is 0, right? Slope is 0 when it is parallel to the x-axis and increasing, and then at y-axis it's infinity. Slope. Does that make sense? And if the slope is go beyond x-axis, go rotate clockwise, passing the x-axis, what happens slope? If the slope is right there, what is the value of slope? Negative. Right? Does that make sense? Okay, good. So this is the, if I recapture 3.1, this is all what we learned. This is it. We come from the secant line and we prove that, the tangent line at a certain point of x is equal to the derivative of that point, right? That's all we talked about. So simple. Its only thing is that you might need to learn a little bit of algebra to solve some of the problems because it involves a little bit. Got it? Okay, so just one thing before I wrap up. I just want to start 3.2, but I'm not sure that I can finish it up. But I can, with the fresh knowledge of this part is easier for you to understand. Now we talked about, do you have any questions before that? Is everything clear on 3.1? Sounds good? Confident about yourself? Okay, do more problems, okay? I'll assign some homework and do that and then get prepared for the next class, okay? All right. Now you learn that f prime a at x equal a can be taken by limit x goes to 0, f of h, f of a plus h minus f of a divided by h. Now, what if I want to find f prime of x at any point? I want to find f prime of x at any point x, right? At any point x. What would I do? Instead of f prime a, right? I want to find f prime x. What do you think that I should write differently? You should be able to guess it now. What do you do? Yes, that's it. So very good, very good. You put limit x equals, sorry, h equals, h goes to 0. Instead of a, you write x, f of x plus h minus f of x divided by h. Now, what is the advantage of this? If you have a function, right? Previously, what we did was we found the derivative at a certain point. Now, with this definition, what we do, we find derivative at any x point. That means derivative is given as a function of x. You know what I mean? Right? So you have a curve f of x. For that curve f of x, you can find a curve for f prime of x. The curve of the derivative function. Right? This is beautiful. So with that information in your hand, you can substitute any x value for that f prime x function, and you can find f prime a, f prime b, f prime c, f prime d, or whatever the value you need. Okay. Now, sometimes you see that y equals f of x, right? Y equals f of x. You see that. And along the same line, you can say f prime x is equal to y prime. Sometimes it's called y prime x. These are notations, nothing big notations. Same thing, f prime x is denoted by y prime or y prime x, right? When you draw graphs early in your grade school and your middle school, maybe in high school, y and x, right? Instead of y, you can write f of x. Same thing, okay? Now, the domain of f prime x consists of all the values of x in the domain of f for which the limit exists. This is the value. So what is the domain of f prime x? Now, f is a function. It has a domain, right? Take this example. Take the example, the very example that we consider, f of x equals magnitude of x, right? So what is the domain for this function? This function is defined for all the x values, right? All the x values. See this one? All the x values, right? Now, what did we find? If I find f prime x, at which point that the limit does not exist? What is f prime x? Is the limit h goes to 0, f prime x plus h, sorry, fh plus x, sorry, not f prime, minus f of x divided by h, right? Now for this function, we found a place that where this limit does not exist. What is that point? We did it earlier. What is the point? Where does the limit does not exist? What point? X equals 0, right? So the domain of f prime x should not consist of x equals 0, right? So domain of f in this case is negative infinity to positive infinity, all the values on the real line, right? But domain of f prime x is what? Negative infinity to 0, right? Union 0 to positive infinity. 0 is not included, right? If you write like that, 0 is not included. Does that make sense? You got it? Right. So like that, you have to find the values that are not, the limit does not exist, and remove that from the domain of that. That's actually mathematically valuable concept, but you need to be careful about where the limit does not exist. So sometimes we say that, sometimes we say that f is if f is differentiable on AB, right? We say f is differentiable if this should be, we say f is differentiable AB if f prime x exists for all the values of x in A, B, right? If you have A to B, right? You have A to B on the real line on the x-axis. If f is differentiable on, we say that f is differentiable on AB if f prime exists for all the values. Now, is it differentiable between -1 and +1 for x magnitude function? Is fx equal x magnitude differentiable between -1 and +1? No. Why? At x equals 0, you don't, it's not differentiable. So it is not differentiable in between -1 and +1. But 1 and 2, yes. In between 1 and 2, it is differentiable. Right? Now, we generally say f is differentiable if f prime x exists for all the values of x in the domain of f. These are some mathematical definitions, okay, that you might need. Right. Does that make sense? So can you give me a couple of minutes to do one example out of that? One example, okay? Just to with the fresh knowledge. You have f of x equal x squared minus 12x. We have to show this is differentiable. What do you mean by differentiable? If it is just say differentiable, that means f prime x exists for all the values of x in the domain of f. What is the domain of f? What is the domain of F? Negative infinity to positive infinity. Very good. All the values of X in the real line would go into that function without any problem. Right. So how do I find F prime of X? Limit H goes to 0, F of X plus H minus F of X divided by H. Right? Does that make sense? So I can write limit H goes to 0, F of H plus X plus H is what? X plus H squared minus 12 times. Sorry, it's a cube, actually cube. This is not a square, this should be cube. It's a cube. Cube, and this is cube. 12 times X plus H minus X cube minus 12X divided by H. Right? So you need to expand this, right? Expand this and then find the solution. So if I want to expand this one, X plus H cube, how do you expand it? X cube plus 3 times X squared H plus 3 times H 3 times 3 times X H squared plus H cube. Right? This is come from the binomial expansion. So if you don't remember, you look at binomial expansion. I'll talk about that a little bit next time. Okay. So binomial expansion, using that, you expand that, and once you expand it, you can solve for this, right? And you can see what that F prime X is. So you should get F prime X is equal to, you should get F prime X equal to, do that at home, see whether you get this answer, X squared minus 12. 3x squared minus 12, I'm sorry, 3x squared minus 12. This is the answer you should get, right? What is the domain of this one? What is the domain of this function? 3x squared minus 12? Negative infinity, positive infinity. That means this satisfies all the values of the domain of F. Domain of F is equal to the domain of F prime X. That means this function is differentiable. If any of the values, at any of the values F prime X does not exist, or the limit does not exist, that means it is not differentiable. Right? It might be differentiable in a given interval, not in the entire domain. Okay, that's it. With that, I will conclude, and thank you very much for hanging there for a couple of minutes more.